Okay, so today we're going to talk about the ideal gas law. So really quick, check out your combined gas law sheet for a minute and pause this video. Okay, so when do we use the combined gas law? When there's a change occurring. Also, you might realize that it's when you see two of any of those variables. So the ideal gas law is now the gas law that we're going to use. Pressure units, volume units, mole unit, temperature units. So we're going to use these variables to solve for one unknown. This is the big idea right now, not Riot. So right now, solving for one of these four variables. So you're going to be giving one pressure, one volume, one moles, or one temperature. You're going to be missing one of those four, and you're going to have to solve for the fourth. Now, when you're performing this ideal gas law equation, let's just say that the pressure P is going to stand for the pressure. I want you to leave a little space to add this later. V is going to equal the volume of the sample. Now, because of something I'll bring up later, or very shortly, the volume must be in liters. And take a second and look at your combined gas law notes, and notice that when we were performing the combined gas law, the volume units just had to match. Well, this time around, the volumes have to be in liters for this to work. Okay, N is going to stand for moles of gas. And sometimes problems, it might give you different information, but make sure you're using the moles of the gas to use PIVNERT, or the ideal gas law. In the ideal gas law, T will represent the temperature. And I think last class we emphasized that this entire unit temperature must always be in Kelvin, and that's going to remain here. Must be in Kelvin, degrees Celsius plus 273. And then lastly, the ideal gas law is going to incorporate this R value. And what is R? R is the ideal gas law constant. Now, I'm going to give you three of them that you might be presented with. So if you are in ATM, R equals 0.0821 liters per ATM over moles Kelvin. And why do I have all these units there? Well, because there's these four variables in the ideal gas law. Now, if your pressure is given in kPa, kilopascals, R is going to equal 8.31 liters per kilopascal over moles Kelvin. And finally, if your pressure is given in millimeters of mercury, I guess, or torr, R will equal 62.4 liters per millimeter of mercury over moles Kelvin. And going back up here now, I hope you'll have some space. What this means is that your pressure, P unit, just must match the R value, P unit. And now in the picture area here, let's see if this is good. The ideal gas law now is just PV equals nRT. And if we have three of these variables and we know the R value is always one of these three right here, and I'm going to mention right now that one of the homework problems, or two of the homework problems tonight, are going to give you a pressure in millimeters of mercury. And like they don't give you the right R value, but I'm giving it to you right here. You would just use 62.4. And then this is the ideal gas law. Again, ideal gas law is solving for problems right now. There is no change going on. Right now, what's the pressure? Right now, what's the volume? Right now, how many moles are there? Right now, what's the temperature? Combined gas law involves change. Ideal gas law involves right now. Combined gas law is P1 V1 over N1 T1 equals P2 V2 over N2 T2. And the ideal gas law is PV equals nRT, PIVNERT. Okay, say it out loud, PIVNERT. Okay, I'm not going to make you memorize this. I will give you this formula always, and I am not going to make you memorize any of these R values. I will always give them to you. We just need to practice when and where to use them. Okay, let's go down and try a couple problems now. So in this first problem, what is the pressure in a 2-liter flask? Okay, I'm going to have you annotate above. That's your V1. Containing 1.5 moles of gas. Okay, there's your N1. At a temperature of 22 degrees Celsius. Okay, there's your T1. Do you notice that this problem doesn't give us any 2's? There's no pressure 2, there's no temperature 2, there's no moles 2. It's just one of each. Secondly, this problem doesn't mention anything about a change. It's saying like, hey, what's the pressure? So this is going to be a Pivner problem. Let's get in the habit of writing this down. PV equals nRT. Now this is a little bit goofy problem because it doesn't ask you for like what pressure unit it wants. So what I would do usually is look at the answers, the answer choices you're given for a multiple choice problem, and then just use that R value. So let's just say hypothetically that all these answer choices were an ATM. Okay, so I'm going to do P times V, the volume is 2 liters. I guess I should do 2.00 liters. That's going to equal N. We have 1.50 moles of gas. Now, I said if our answer choices are all in ATM, let's just make sure we use this 0.0821 R value. So we'll do times 0.0821 times T, and let's make sure we put that in Kelvin, 295 Kelvin. Now, if we're solving for pressure and we have this R value is in ATM, we end up with like about 18.2 ATM. Okay, question 2, how many moles of gas are in a 20-liter tank? Okay, there's your V1. At a pressure of 0.25 ATM, there's your P1. At 12 degrees Celsius, there's your T1. So why is this the ideal gas law? Well, it's on the piece of paper that says ideal gas law, so that's why. Also, it doesn't mention change, and it doesn't mention any 2's. So I know, again, that we're going to be doing Pivner stuff here. Okay, so it says my pressure is 0.25 ATM. My volume is a 20-liter tank. Solving for N. Now this is where the pressure is in ATM, so we look up here and we make sure to use the R value that has ATM in it, 0.0821 again. And then my temperature is 12 degrees Celsius, which would be 285 Kelvin. Try and solve on your own for N, and then we get 0.21 moles. Okay, question 3. What's the temperature in a sealed rigid container with a volume of 233 milliliters? And I hope you're kind of keying into that milliliters unit. So there's our V1. Containing 1 mole of gas, there's your N1. At a pressure of 1.50 ATM, there's your P1. So there is no change going on. There are no 2's. This is a Pivner problem again. Okay, my pressure was 1.50 ATM. My volume was 233 milliliters. Remember that volumes today must be in liters because that is the unit in these R values. So we got, what, 0.233 liters. We're solving for temperature, it looks like. So we got 1 mole of gas in there. My pressure is given in ATM, so I'm once again going to use that 0.0821 liters per ATM over moles Kelvin. And then we're solving for temperature this time. Okay, this time when you solve for temperature, temperature equals 4.3. And let's be very careful that that's 4.3 Kelvin. Now, I would say in a class like our class, where I love to make you very attentive to units and be careful, I could then give you the answer choices in degrees Celsius. So remember, if we had to convert this backwards into degrees Celsius, we would like subtract 273 to get what, like negative 269? Okay, lastly, what's the volume of a container that contains 0.05 moles of gas at 2.4 ATM and 22 degrees Celsius? I have N1, I have P1, I have T1. I guess we're doing PivNerd again. Okay, so my pressure is 2.40 atm. My volume is unknown. N is 0.05 moles. Since my pressure is in atm, we would do 0.0821. And my temperature is 295 Kelvin. So we solve for V, and we end up with 0.5 liters. Okay, I'd like you to try question 4 over here on your own. And the main reason why I'm doing this, I'm trying to, again, sneak something in ahead of time. And I would like you to read this and try it on your own. And just pause the video. Okay, now, what is the volume of 1 mole of gas at 0 degrees Celsius? So everyone, STP, and maybe you can annotate it up here somewhere, or here, just do this. STP stands for standard temperature and pressure. Now, standard temperature is 0 degrees Celsius. Now, that equals 273 Kelvin. It's just a value. It's just something we told. It's not like, or we tell you, it's not like an average or anything. It's just this value that we call standard. Standard pressure is 1 atm. Well, again, although probably one of the most common pressures is about 1 atm, that's not why it's standard. Standard is just this random value we've assigned as 1. Now, later on, we are going to learn that we can use STP values as a shortcut method. And I just want to sneak this in ahead of time that STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin, and standard pressure is 1 atm. Okay, so now what's the volume of 1 mole of gas at 0 degrees Celsius and 1 atm? So again, we have an N1, a T1, and a P1, so this must be a PivNerd problem. We're only given one of each variable. There's no mention of change. My pressure is 1 atm. My V we're solving for. My N was 1 mole of gas. Because we're in atm, we're going to use 0.0821. And the temperature would be 273 Kelvin. And when we solve for this, V equals 22.4 liters. So I would like you to circle this and highlight this. What this means is that any gas at STP, 1 mole of it is 22.4 liters. Let's go like this. Okay, there we go. So what this means again is that any gas at STP, 1 mole of it will occupy 22.4 liters. And this is going to end up being a little shortcut we use next class. Okay, I'd like you to now use the ideal gas law and practice some problems and review and try and figure out when to use ideal versus combined gas law. Okay, you got this. Good luck.